Probability and segregation. Look again at figure 11-7. 1/4 of the F2 plants have two alleles for tallness, homozygous dominant or big T big T. 2/4 or 1/2 of the F2 plants have one allele for tallness and one allele for shortness, or heterozygous, big T little t. Because the allele for tallness is dominant over the allele for shortness, 3/4 of the F2 plants should be tall. Overall, there are three tall plants for every one short plant in the F2 generation. Thus, the ratio of tall plants to short plants is 3:1. This assumes, of course, that Mendel's model of segregation is correct. Did the data from Mendel's experiments fit this model? Yes. The predicted ratio, 3 dominant to 1 recessive, showed up consistently, indicating that Mendel's assumptions about segregation had been correct. For each of his 7 crosses, about 3/4 of the plants showed the trait controlled by the dominant allele. About 1/4 showed the trait controlled by the recessive allele. Segregation did indeed occur according to Mendel's model. Probabilities predict averages. Probabilities predict the average outcome of a large number of events. However, probability cannot predict the precise outcome of an individual event. If you flip a coin twice, you are likely to get one head and one tail. However, you might also get 2 heads or 2 tails. To be more likely to get the expected 50-50 ratio, you would have to flip the coin many times. The same is true of genetics. The larger the number of offsprings, the closer the resulting numbers will get to the expected values. If an F1 generation contains just 3 or 4 offspring, it may not match Mendelian predicted ratios. When an F1 generation contains hundreds or thousands of individuals, however, the ratios usually come very close to matching expectations.